Let's look at problem F. In our case, it's two signals multiplying together. The first signal is sine pi t over pi t, which is a sinc signal. It's from the Fourier transform pairs in our Fourier transform sheets. So we know what its Fourier transform looks like in the frequency domain with a magnitude of 1 from negative pi to pi. And the second signal's sine 2 pi t minus 1 over pi t minus 1. If you look at the signal, you will realize it's a sinc signal with a time shift. We know the time shift property is on the basis of this signal's Fourier transform times e to the negative j omega in our case, because you shift to the right by negative 1. And we know what this sinc signal like is from 2 pi, negative 2 pi to 2 pi with a magnitude of 1, right? So we know what our x2 j omega looks like will be from negative 2 pi to 2 pi with the magnitude of e to the negative j omega. So now all we need to do is to do regular convolution on continuous time signal with a variable of omega. Because recall the multiplication property is when two signals multiply together in the time domain, in their frequency domain, it's actually their Fourier transform convolution times 1 over 2 pi. Don't forget about this part. It's really easy to ignore. So now what we need to do is to do this convolution. Recall what we learned from a continuous time convolution. Xt and ht do convolution. It's the integral of x tau ht minus tau to the variable of tau. So in our case, we keep x2 j omega as the xt here. Keep x1 j omega as the h here, because x1 j omega is simpler, so it's easy to manipulate, do the time reversal and do the time shift. So in our case, we need to find the variable like tau for our omega. Let's just call it omega prime. First, we draw x2 j omega prime. It looks something like this, from negative 2 pi to 2 pi with the magnitude of e to the negative j omega prime. And then we need to do x1 j omega prime and do the time reversal, x1 negative j omega prime, and then shift to right by omega. So in our case, since we're symmetric over y-axis, so when we do negative time reversal, the negative j omega prime is actually look exact the same as x1 j omega prime. And then we shift to right by omega. So it was supposed to look something like this. Because we shift to the right by omega. So now we found the inner part of the integral, right? We need to do multiplication on these two signals. So we just find the different interval. So the first interval, let me draw here, negative 2 pi with the e negative j omega prime. Let me change the color. So the first interval is when your x1 j omega prime move along this omega prime axis, and first it encounter with the signal from negative omega minus pi to omega plus pi with the magnitude of 1. So this is our first overlap. In our case, it's when omega minus pi smaller than negative 2 pi smaller than omega plus pi. And we were able to find our first time interval. Omega from negative 3 pi to negative pi. So here, our x1 j omega with x2 j omega convolution times 1 over 2 pi is equal 1 over 2 pi integral of 1 times e to the negative j omega prime. And here it's actually from negative 2 pi to omega plus pi. Let me erase this to make it look clearly. And if you calculate this, remember e to the j 2 pi or e to the j pi or e to the j negative pi, it has real value. So don't keep this in your final answer because that's not a concise answer. So if you calculate this, it's actually j over 2 pi negative 1 times e to the negative j omega minus 1. This is our first interval. Now let's find our second interval. Let's draw this signal over here, again to the negative j omega prime. And your other signal is moving. until it moves inside. And if we do the same thing, first we find an interval negative 2 pi smaller than omega minus pi, omega plus pi smaller than pi. We were able to find the interval omega from negative pi to pi. If we do the same integral here from omega minus pi to omega plus pi, which is the overlap, e to the negative j omega prime, we were able to find this integral is actually 0. And then it was the last case. Still, let's draw the signal here. I'm sorry, forget about the 2. And our signal is still moving along the omega prime axis, and the move outside a little bit. So this interval is when omega minus pi smaller than 2 pi, smaller than omega plus pi, which is from pi to 3 pi. And we do the same integral here. The overlap would be omega minus pi to 2 pi, e to the negative j omega prime, and then we were able to find the answer. The calculation part is not hard. And if we represent our final answer, it will be from negative 3 pi to negative pi, we have this answer. From pi to 3 pi, we have this answer, and otherwise it will be 0. So let's summarize this problem. First, we saw this type of problem is a multiplication of 2 signals. And actually, it was 2 signals that we know of. We know what is Fourier transform like. It's a sync signal with a time-shifted sync signal. So we need to use the multiplication property, and we were able to know in the frequency domain it's actually convolution. And very important, don't forget about this 1 over 2 pi in this property. And then, since we were able to find x1 j omega and x2 j omega, we can start doing convolution. We just treat this x1 j omega and x2 j omega as a continuous time signal with a variable of omega instead of how we used to do, which is t. So it's the same thing. For one of the signal, we do the time reversal, we shift to right by omega in our case, and we move it along the omega prime axis to find the different overlap, to find the different time interval. And we calculate the integral, and we got our answer.